Hi Roger, my name is Aftab. I go to the University of Washington where I study computer science, and I also work as a research assistant on predictive analytics in healthcare. Now I know that all of your fans really want you to win Wimbledon this year, and I being a huge fan of yours come in the same bracket. So I have applied my knowledge of computer algorithms and my research experience in artificial intelligence to create a software which analyzes your game. Now the first thing the software does is to create a data set from all of your previous matches against Novak, and this includes everything from the usual aces, first serve break points to more in-depth data such as rally length or depth of the return or serve direction and so on. And once it gets this data, it creates a machine learning model which analyzes your game. And this is a self-learning model, which means that the more data you give it, the better it's able to learn and understand your game and come up with key patterns. So I want to tell you a couple of things the software does. First, given basic stats about the match, it can predict the outcome of that match, the winner, with an accuracy rate of 76%. That is 3 out of 4 times correctly. But it doesn't stop there, it goes a step further, and for each match it comes up with a set of key contributing factors that actually affected the outcome of the match. So these are like actionable items that you can work on to change the outcome of that match. I want to show you 3 key patterns discovered by the software. First, serve direction. This is a visualization tool I made which gives a good Hawkeye view of serve placement. I know the net here needs a little bit of work, but anyways, so I was curious to see if there's any changes in serve pattern between the Wimbledon semi-finals of 2012, which of course won, and 2015 finals that you lost. So I went about visualizing these, and what I see is that this is 2015 and this is 2012, by the way. So what I see is that in 2015 there's a huge portion of serves onto the wide side in both the deuce and the ad court, but in 2012 there's a higher percentage of serves on the mid portion. I just thought it's an interesting observation because it's not a minuscule delta that we're talking about. It's about a 15% jump on both of the sides. Second, rally length. Keep the rallies short. This is a split up of win percentage based on rally length. So as you can see, for rallies that have just 1 to 3 or 4 to 6 exchanges, you have a higher percentage chance of winning those rallies. But once the rallies get longer beyond 7 points, Novak starts holding the edge, and once it gets to 10 exchanges, he has a much higher chance of winning those rallies. Third, unforced errors have a higher impact on predicting the outcome of the match as compared to winners. One of the concepts used in artificial intelligence is something called a decision tree, where at every step the system makes a decision and sees how it affects the final outcome. So I made a decision tree of all of your matches against Novak, and I want to show you a couple of things here. So one is that given basic stats such as aces, double faults, winners, unforced errors, the software can predict the outcome of a match with an accuracy rate of up to 76%. So since it gave a good accuracy, I was curious to see which factors affect the decision making the most. And what I see is that unforced errors have a 42% saying on the match outcome. The winners are pretty much at the bottom. It just has a 5% say on the decision making. So this was quite interesting, and I wanted to see how unforced errors have such a telling difference on the match outcome. So these are the stats for the matches that you won on the left side, and these are the stats for the ones that you lost. So if you see the winners, you still hit pretty much the same number of winners on an average in both the matches you win and the ones you lose. But it's the unforced errors that have such a telling impact. In the matches you win, you hit about 30 unforced errors, but this jumps to such a higher number in the ones that you lose. So this is how the decision tree can take advantage of this attribute and say clearly whether you would win or lose that match. I want to thank you for listening throughout the length of the video. I understand that a lot of the things that you do on court are quite instinct based, and that's why we all love your game so much. But for me, the whole purpose of making this machine learning software was just that, as we see in school, for humans as well as machines, learning is a continuous thing. And I just felt that if I could contribute in even a small way to your game, or some change in the thought process, it's going to be a huge achievement for me, not just as a fan, but also a computer science student.
I also want to thank you for all the years of entertainment that you've given us and the ones you will in future. And what is so special about you is that through your game, you not only inspire kids to pick up the racket, but you also inspire people who have really nothing to do with the sport. For example, the whole time that I was working on my software, I was so motivated and was able to learn so many new concepts and came up with so many new ideas that I probably wouldn't be so motivated maybe if I was working on something else. So thank you so much, and let's go Wimbledon.